Hello everyone, welcome to this video. My name is Chirag and I welcome you all on the behalf of PyNet Labs. So in this video we are going to solve the assignment number 6 which was posted in the Telegram group of PyNet Labs. Now these assignments are part of $100 giveaway. So if you do want to participate in such giveaways, make sure you join the Telegram group from the link given in the description. So let's quickly get started and let's see what do we have to cover in this assignment number 6. Okay, so we have this assignment number 6 here on the screen. It asks you to, in the task number 1, it asks you to configure the IP addresses and OSPF. Then task 2 and task 3 is about configuring standard access control list. After that, task 4 is about configuring extended ACL on router number 3 and router number 4. So let's get started. I have a similar topology ready with me in this packet tracer. So we'll begin the configuration from router number 1. Let's begin it from assigning the IP addresses first. I'll say enable config t host name r1. On interface fa0/1 I'll put the IP address 12.0.0.1. Put the subnet mask. Okay, just a second.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
There you go. And say no shutdown. Then on interface fa00 I'll say IP address 13.0.0.1 255.255.255.0 and no shutdown. Exit. Then we'll move to router number 2 and we'll put the IP addresses there. In the CLI I'll say enable config t host name r2 interface fa0/1 IP address 24.0.0.2 255.255.255.0 no shutdown. Interface fa0/0 IP address 12.0.0.2 with the subnet mask and no shutdown. Exit. Then router number 3 CLI interface fa01 I'll put the IP address 192.168.1.1. On Ethernet 1/0 we will have the IP address 192.168.2.1. Add the subnet mask and say no shutdown. On interface Ethernet 1/1 we'll have the IP address 192.168.3.1 255.255.255.0 and no shutdown. Exit. We are done configuring the IP addresses on router number 3. Let's move to router number 4 now. CLI there. Enable config t host name r4 interface fa0/0 IP address 24.0.0.4 255.255.255.0 no shutdown. Interface fa0/1 IP address 192.168.4.1 and say no shutdown. Interface Ethernet 1/0 IP address 192.168.5.1 255.255.255.0 no shutdown. Interface Ethernet 1/1 IP address 192.168.6.1. Add the subnet mask. No shutdown. Exit. Now we are done assigning the IP addresses. Let's also create the DHCP pool so that these end devices can get the IP from the router. I'll go to router 3 IP DHCP pool A for the network 192.168.1.0. The gateway address is going to be 192.168.1.1. Then IP DHCP pool B for the network 192.168.2.0. And the gateway address is going to be 192.168.2.1. then again IP DHCP pool C for the network 192.168.3.0, and the gateway address this time is going to be 192.168.3.1. exit. Then I'll go to router 4, will create 3 DHCP pools for these 3 networks. IP DHCP pool A for the network 192.168.4.0, and the gateway address will be 192.168.4.1. Then IP DHCP pool B for the network 192.168.5.0, and the gateway address as 5.1. I'll just say no IP DHCP pool B. Then IP DHCP pool C, IP DHCP pool C for the network 192.168.6.0, 255.255.255.0 with the gateway address as 192.168.6.1. There. Now I'll assign the IP address to these end devices. PC0 IP DHCP, perfect. Okay, so now my next task would be configuring OSPF. This R1 and R2 will be in OSPF area 0, and area 10 and 20 will be there for R3 and R4 respectively. So let's put them in their respective areas. I'll go to router number 1 and we'll begin the OSPF configuration. Say router OSPF 10, we'll set the router ID as 1.1.1.1, exit. Interface FA0/1 will be a part of IP OSPF 10 area 0. Interface FA00 will be a part of area 10, exit. Similarly, I'll go to router 2 and we'll put the configs there. Router OSPF 10, router ID 2.2.2, exit. Interface FA0/0, IP OSPF 10 area 0, then interface FA0/1, IP OSPF 10 area 20, exit. After that, router 3, all the interfaces will be the part of area 10. So router OSPF 10, router ID will be 3.3.3.3. Select the interface range. Say IP OSPF 10 area 10. Interface range of Ethernet ports 1/0 to 1. Say IP OSPF 10 area 10. Just like that on R4 also, I'll select the range, interface range FA0/0 to 1, comma Ethernet 1/0 to 1. I'll say IP OSPF 10 area 20, exit. Then if I just simply go to router 3 and say show IP route there, so I have all the routes there inside the routing table of this router. If I go to PC0, go to the command prompt and say ping 192.168.5.2, let's say, So we are getting the reply. That means the communication is there. The devices are able to communicate, right? Now let's see what do we have next to configure inside the assignment. So it asks you to configure standard ACL to restrict the communication from VPC 11 and the networks connected to R4, which are 4.0, 5.0 and 6.0. Then again it asks you to configure ACL for restricting the communication between 2.0 and the networks connected to R4. So in this topology, VPC 11 is the first PC of network 192.168.1.0, which according to this topology will be PC 0. So let's put this configuration on R4 first. You can create two ACLs, or you can even define both of the things in the same ACL. So I'll say access list 10 deny host 192.168.1.2, which is the IP of PC 0. Then I will say access list 10 deny 192.168.2.0 network with the 0.0.0.255 as the wildcard mask. Other than that, I would say access list 10 permit any, so that the rest of the traffic can be permitted. After this point, we also have to apply the ACL on the interfaces. So I'll apply it on the interfaces of R4. I'll select the range interface range FA0/1, Ethernet 1/0 to 1, and we'll apply it there. Config T interface range FA0/1, Ethernet 1/0 and 1. We'll say IP access group 10 for basically outbound packets 10. Now if I go back to PC 0 and try to ping it again, we are getting this prompt as destination host unreachable. That means the ACL is working there, and since we were getting the reply earlier, we can confirm that the communication was there or SPF configurations were correct. But after configuring ACL, the communication is getting denied. But if I try it from PC1, let's say, it should get successful. So I'll say ping 192.168.5.2. As we can see that we are getting the reply, this means that the communication is only being denied particularly for PC0. Then PC2 and PC3 should also not be able to communicate with any of these three networks. I'll just go to PC2 and will randomly ping 192.168.6.3, let's say. So we can see that the communication is not getting successful. It says destination host unreachable. So we can assume that we have successfully configured task number 2 and task number 3 also. Now the next thing is to configure extended ACL on R3 and R4 to avoid telnet connectivity from any indirectly connected route. So my R3 should only be the people who are connected with the network 1.0, 2.0, 3.0 should be able to get the telnet connectivity from R3. Otherwise, the person shouldn't be able to have that connection. So we have to configure ACL in that way. So what I'll do is, before that, I'll first of all put the configurations of telnet on these routers. So config T line VTY, okay, 0/4, and would say password, we'll set the password as CISCO. Then after that say login exit. Then I'll also set an enable password as PyNet. Similarly, I'll go to router number 4 and we'll configure telnet there. Config T line VTY 0/4 password CISCO login exit enable password PyNet end. Now currently, if I just try to get telnet, if I just try to telnet this router number 4 from this PC1 192.168.5.1, it is asking me for the password, and if I put the correct passwords, it will allow me to access the router. There. So it is allowing a device from indirectly connected route currently, but after configuring our extended ACL, this shouldn't be possible, right? So let's go to R3 and configure the ACL so that only the directly connected routes can have the telnet connectivity with the router. So I'll say access list 101, then I'll say permit TCP for the source 192.168.1.0 0.0.0.255, then we can say we have to define the destination. So the destination can be 4 addresses for router number 3. So I'll say for host as 192.168.1.1, then you also have to define the particular port number of the telnet. So I'll say equals to 23, or you can either way, like you can also say telnet there instead of 23. Now I have defined it for just 192.168.1.1. I'll do it for 192.168.2.1, then I'll do it for 192.168.3.1, then I'll do it for 13.002, which is FA00, 13.002. Now this is only permitting 192.168.1.0. In the same manner, I have to create the rules for 2.0 and 3.0 also. So let me quickly do that. I'll just change it to 2.0, then again 2.0. And there. So now for 2.0 also I have defined all the 4 addresses 192.168.1.1, 2.1, 3.1 and 13.002. Okay, let me just quickly see. Show IP interface brief. Do show IP interface brief. Okay, I have 13.003 instead of 2 on FA00. I'll just correct that. Interface FA00. And I'll update the IP address to 13.002 255.255.255.0. Exit. Show IP interface brief. Perfect. So now after updating the IP address, we can say this configuration of ACL is correct. Now I also have to define it for network 192.168.3.0, right? I'll just copy this, paste it here and make the changes. So this is going to be for 3.0, right? Then we will make it for the host address as 192.168.2.1, then for the host address 192.168.3.1, and then 13.002. After this, after permitting 192.168.1.0, 2.0 and 3.0 for all the 4 host addresses, which is 192.168.1.1, 2.1, 3.1 and 13.002, we also have to permit the ICMP packets and the OSPF packets. Otherwise the communication will not be there, and if we don't permit the OSPF packets, then the neighborship will be broken between these devices. So I'll say access list 101 permit ICMP any, then access list 101 permit OSPF any, and then I just have to apply it on the interfaces. So we can just simply apply it on the interface FA00, which in this case can be considered as the WAN interface. So I'll say interface FA0/0 and we'll apply it there. IP access group 101 for inside direction end. Now after this point, my PCs from these networks shouldn't be able to have the telnet connectivity with R3. I'll just quickly check that. I'll go to the command prompt and we'll say telnet 192.168.1.1. There. So it says trying, and Let's see if it works or not. The connection timed out and remote host is not responding. Now we are getting this prompt because of the ACL which we have configured. But still, if I try to ping the IP 192.168.1.1, we are getting the reply. That means ICMP communication is still there, but the devices cannot build telnet connections with the R3 because they belong to a network which is not directly connected to R3. The assignment asks you to configure something similar on R4 also, which I'll be leaving for you guys. And you just have to manipulate the IP addresses for R4, and the rest of the configuration will be same as we have done for our router number 3. And then we can say that we'll be completing the whole assignment. So I hope you guys enjoyed the video and got to learn out of this. Make sure you try to practice this, and I'll see you in some other video. Till then, take care. Bye bye.